Morning, guys. So today we're going to work on an excerpt from the BMI Lab. This is Freefall. Now, Freefall is a physics concept you'll hear about. So it does take gravity into account, but it's usually not influenced too much by things like friction or wind resistance, just like if we just drop something unimpeded, what would happen? And so I've already got my skeleton set up. I've got my import because I'm getting user information from the user. I've got my scanner named scan in this case. So let's start the problem. Prompt the user, asking them to enter a floating point, or a double for us, value. Save their response as a variable time. Write code to print the distance a brick would free fall if dropped from a tower in time seconds. Remember, sample run is shown below. So we ask them for their seconds. They say 5.4, a double. And distance traveled gives us 469.096 feet. Now, we did give you the gravity. It's the gravity factor. I mean, it varies a little bit depending on where you are on Earth, but we call it a constant. 32.174 feet, we can declare that. One thing we did not provide was the formula for free fall, which is kind of odd. So I'll make sure I add it in future years. But it's right here, 1/2 times gravity times time squared. And yeah, so let's get started. So very simple outline this time. So I need my quick prompt. I'll do my math, and then I'll do my print statements. That's all it is. Prompt, as always, need to give the user instructions. So I give a quick print statement. And I'm just going to copy what they told us to use. Boom. Now I need to make a variable. So double time equals scan.next double. And I'm set. All right, for math, I do need to go ahead and plug in gravity. Let's see, what did they give us for gravity? 32.174. And then I just start my solution. So I'm also going to make a double, and we'll call it distance, because that's what we're measuring. And here's the biggest problem. I see a lot of people just kind of, I know I like copy pasting, and I still support that. G is taken care of, T is actually time. And then they get stuck right here. They're like, well, Mr. Gerald, it's erroring. Yes, there's a couple of things going on. First off, remember, exponents don't exist in Java the same way they do in math, so we can't do this. We've got two different methods we know, so we could just simply say, okay, time times time. That takes care of it, okay? The other problem that we see, and I guess I'll go ahead and include the other option as well, because you could also just do math.pow time 2. So that's the other option for exponents. Okay. The other problem we see right here is this isn't an error, but this is not the correct solution, because this part right here is going to fail our code. Remember, we've got two different types of division in Java. So we've got modular division, and what we've got here is integer division. And so if we see an int divided by an int, that means my answer is going to give me an int, which means 1 divided by 2 is 0. That's going to mess up the entire rest of the equation, because 0 times anything is always 0. So we can't use this. So I'm going to just force code the literal value, 0.5, right there. Other options you could do 1.0 divided by 2, or 1 divided by 2.0. Okay, so just be aware, we can't do the 1/2 unless we do a casting, which we've talked about that, so I guess I'll include that as well. So treat this as a double. 1 divided by 2. Okay. So I've got 3 other alternatives depending on how your mind works, all of which are acceptable, all of which are full credit, no penalties. Okay. After that, that's going to calculate my value. All I need now is my print statement. And just like before, I'm going to copy their wording. And this time I'm just going to concatenate to use my answer. Okay. So there's the whole problem. Let's run it with their sample code. Do a quick check, make sure we're getting the right values. 5.4. And there you go. Slightly different with decimals, but that's because of the IDE we use. Until I teach you how to limit that, that's fine. I'm not going to ding you for that. That's it. Have a good one.